Good day everyone. In the last video, you learned two models in integration by parts. Now, let us see model 3. What is model 3? Here, you will be using integration by parts two types. Example 1. I is equal to integral sine inverse x the whole squared dx. Here your integrand is sine inverse x the whole square. So that will be your u, right? U is equal to sine inverse x the whole square. Then naturally only the dx part is there. That will be your dv. So now you write dv is equal to dx. Then you remember what you will do? Differentiate the u function. Integrate the dv function, right? So now let us differentiate. Du is equal to, here you have to use chain rule or function of a function in differentiation. Okay, so you will get 2 sine inverse x. Then the differentiation of sine inverse x is 1 by root of 1 minus x squared, then dx. Okay, now let us integrate here. You will get v is equal to x. Now you know u, v, du, dv. What is the formula in integration by parts? Only one formula I told you, right? So, integral u dv, that is equal to uv minus integral v du. The left hand side as usual will be your I have told you already. So, this will be I. That will be equal to u into v. So, it is x into sine inverse x the whole square minus integral. What is v now? X. Then du is 2 sine inverse x into 1 by root of 1 minus x squared dx. Okay. So now the first part let us write as it is. The second part I will take the 2 outside the integral. So I will get actually sine inverse x into x by root of 1 minus x squared dx. If you look at the v du part, here you have a product of 2 different functions, that is sine inverse x, one inverse trigonometry function, and an algebraic function x by root of 1 minus x squared. So you know, when you get a product of 2 different functions, that is your model 2, isn't it? You have learnt it. So now the v du is not straight away integrable. We have to again use integration by parts. So now let us write it as it is. That is I is equal to x sine inverse x the whole square minus 2. Let me represent this integral as I1, because if I just proceed it will be too much confusing. So you write it is I1, mark this as step 1. We will come back to this step 1 later. Now we will consider I1 alone. We will use integration by parts, integrate it, and then we will come back to I. Okay. So now let me write I1. Now that is a separate sum actually. I1 is sine inverse x into x by root of 1 minus x squared dx. Now you have to use isolate rule. You remember, whenever you have a product of 2 different functions, to identify the u function, use the rule isolate. Now I is inverse trigonometry, that one, and this is a. I comes before a. So now you will have u as sine inverse x and the rest will be dv. So now I1, okay, I will write again here sine inverse x into x by root of 1 minus x squared dx. Now u is sine inverse x and dv will be x by root of 1 minus x squared dx, right? Now, if you differentiate, the du will be 1 by root of 1 minus x squared dx. Here we have to integrate. You know, the integration is not straight here. We have to use the method of substitution. Like this you have done a sum already. So here, for this alone, this I will keep as it is. 1 minus x squared I will substitute as t, whatever is within the square root. When I differentiate, I will get minus 2x is equal to dt by dx, or bring the dx here, x dx will be minus 1 by 2 dt, right? So now the integral dv will be now equal to integral. This minus 1 by 2, let me write here. The x dx, for that I will write the dt because minus 1 by 2 already I have taken, by the denominator will be root t. Okay? Now I can write this as minus of integral t power minus of dt. Now I can integrate both sides. So we'll get v is equal to minus 1 by 2 into, when you integrate you will be getting t power half by half. This half and that half will get cut. You are getting then minus t power half. That will be minus root t. What is t? T is 1 minus x squared. So you will get minus root 1 minus x squared. That is your v now. Now the same formula as usual. What is the formula? Integral u dv is equal to uv minus integral v du. Now the left hand side is not I, that will be I1 because that is our sum. So now you will be getting here I1, that is equal to u into v. U is sin inverse x, v is minus root 1 minus x squared. So I will write this first and then I will write sin inverse x minus integral v. V is minus root 1 minus x squared into du is what? 1 by root of 1 minus x squared dx. Now see, the root 1 minus x squared will get cut here. Okay. This minus if you take out, that will become a plus. So within integral you will get integral dx, that is x. So now I will write minus root 1 minus x squared sin inverse x plus x. Then I will put 1c. This is my I1 and I will mark it as step 2. Do you follow? Actually we have now done like two sums. First we have used integration by parts. We got this. Then we have taken the I1 and we have got the answer. Now we have to substitute the 2 in 1. Okay? Now let us do that and get the final answer. Let us substitute 2 in 1 now. So we will get now I is equal to, okay, x sin inverse x the whole square minus 2 into I1. For I1 I will get minus root 1 minus x squared sin inverse x plus x. I will put the c here. So now let me write it properly. X sin inverse x the whole square, minus into minus is plus 2 root 1 minus x squared sin inverse x minus 2 into x minus 2x plus c. Okay. So even though it's a bit lengthy, if you do it carefully, organizing your sum, then it is easy only. It is like two sums, that's all. Okay. Is this sum clear to you? Shall we do one more example of this type so that you will understand it more clearly, right? In the first example, we had the integrand as sin inverse x the whole square, and in the VDU part, you got another product of two things and then you proceeded further. See the example 2 here. I is equal to integral x log x the whole squared dx. So in the starting itself, you have two different functions. Okay, x is an algebraic function and that log x the whole square, that part is an logarithmic function. So if you apply the Eilert rule, L comes before A, so you will get your u as log x the whole square, right? Then your dv will be x dx. So the dv will be x dx, right? Now let me differentiate u function. What will I get? Du is equal to, again here chain rule, function of a function. Okay. So first 2 log x into 1 by x. Okay. then dx. Here you integrate v is equal to x squared by 2. So, we got the du, we got the v also. Write the formula. Integral u dv is equal to uv minus integral v du. Check whether you are getting the I now. Log x the whole square x dx, right? So, now I, that is equal to u into v. So, I will get x squared by 2, then log x the whole square, okay? Minus integral v. What is v? X squared by 2. Du is 2 into log x into 1 by x dx. Now, this is one part of your answer. Keep it as it is. Here, this 2 and this 2 you can cancel. And 1x here will go 1x. So, actually you will be now getting x squared by 2 log x the whole square minus 1x is here and 1 log x is there dx. Here again you can notice you have a product of two different functions. So, definitely we have to apply integration by parts again. So, now I will write I is equal to x squared by 2 log x the whole square, okay, minus I will put this as I1 and call this as step 1. So, now I am going to consider I1 and integrate it as a separate sum. So, now what is I1? I1 is integral x log x dx. X is an algebraic function. Log x is logarithmic function. So, now the u will be log x here and dv will be x dx, right? Now, what is du now? It is 1 by x dx. V will be x squared by 2, right? So, now let us write the formula. Integral u dv is equal to uv minus integral v du. Now, the left hand side is I1. Remember that. So, right now I1 is equal to u into v, that is x squared by 2 into log x minus integral v. V is x squared by 2. Du is 1 by x dx. 1 by x dx. Okay? You can cut 1x. So that will go. So you will get x squared by 2 log x. Take the 2 in the denominator out. You will get x dx. This is a very simple one. You can integrate. So you will get it as x squared by 2 log x minus half into x squared by 2. Then put one c there. This is I1 and mark this as step 2. As you have done the previous sum, substitute 2 in 1. Substitute 2 in 1. So, now our 1 is I. So, I is equal to x squared by 2 log x the whole square, then minus I1. So, put a minus sign here, then within bracket x squared by 2 log x minus x squared by 4, then write the plus c. Now, I will remove the bracket x squared by 2 log x the whole square minus x squared by 2 log x plus x squared by 4 plus c. Actually, x squared by 2 is common. We can take that common out so that we will be getting x squared by 2 out. I will be getting log x the whole square. Here x squared by 2 we have taken, so minus log x. Here you will get 1 by 2 plus. Do you understand this model 3? How to integrating by parts? You are using it 2 times. That model, I think it is clear to you. So now let us go to another new concept and a new formula. Actually, that is based on this integration by parts only, but we will be learning it as a formula and we will use it. No need to know the derivation, how it comes and all, but it is based on integration by parts. Okay, we will go to that now. For integrals of type integral e power x into f of x plus f dash of x dx, that is, you will have an e power x. Then you will have two terms. If you take one term as f of x, the other term will become f dash of x. For such integrals, straight away we can write it as a formula, that is integral e power x into f of x plus f dash of x dx is equal to e power x f of x plus c. That's all. Okay? You need not do the whole process. You can use the formula and write. Now, let us see one very straight sum first, which is of this particular type, this model. Okay? I is equal to integral e power x into 1 by x squared minus 2 by x cube dx. Now, this particular sum can be asked in an MCQ. If they ask you in the MCQ, no need of any steps, isn't it? So here, if you see, if your f of x is 1 by x squared, you know the f dash of x is minus 2 by x cube. So you can straight away tick the answer e power x into 1 by x squared plus c. Because you know this formula, so you can write that f of x, e power x into f of x plus c. Straight away it is over. But supposing it is a bit subjective, if they give you in a 1 mark working type of sum or in a 2 mark sum, in that case you have to write a few steps. So let me tell you that steps also. Okay? So here, whenever I see this e power x and 2 terms, especially in this sum, it is very straight. Always it will not be. Let us see some more examples afterwards. So now here I will write like this. F of x is equal to 1 by x squared. Okay? Then, if I differentiate, what will I do? I will take the x squared to the numerator, that will become x power minus 2. So, it will become minus 2 x power minus 3, which is minus 2 by x cube. So, f dash of x will be minus 2 by x cube. Okay? Then I will write I is of the form. You have to write I is of the form integral e power x into f of x plus f dash of x dx. Therefore, I is equal to e power x f of x plus c. If it is of this form, this is the answer. So, write these 2-3 steps. Then you will know I is equal to e power x into 1 by x squared plus c. Right? So, a very simple sum. Definitely, if you know the formula, you will be able to do this because it is a very straight f of x and f dash of x. Now, let us see another example. See the second term. I is equal to integral e power x into 1 minus sin x by 1 minus cos x dx. Definitely, you know, straight away, nothing is f dash of x and nothing is f of x. You can't exactly fit them, right? So here, we should use some trigonometry formula and bring it to that format like f of x plus f dash of x. Okay? So, I have already told you, you should remember all the trigonometry formulae. That will be really useful for any integration sum. So, now, sin x can be written as using half-angled formula 2 sin x by 2 cos x by 2. Then you know 1 minus cos x is equal to 2 sin squared x by 2. We are going to make use of these two formulae now. So here I will get integral e power x into 1 minus 2 sin x by 2 cos x by 2 by 2 sin squared x by 2 then dx. Okay, this is the first step. Then I am going to write this as two parts, that is e power x into 1 by 2 sine squared x by 2 minus 2 sine x by 2 cos x by 2 by 2 sine squared x by 2 dx. Okay, I am just writing them as two parts. In the second part, this 2, that 2 will go. 1 sin x by 2 will go. So you will get cos x by 2 by sin x by 2. So now I can write it e power x into, this is 1 by 2 cosecant squared x by 2 minus cot x by 2 then dx. You know, if you differentiate cot x by 2, you will be getting minus cosecant squared x by 2 into 1 by 2. So now I am going to take one minus outside. So I will get e power x. I will write cot x by 2 first, then minus 1 by 2 cosecant squared x by 2 dx. Now it is easy for us. This is f of x, that is f dash of x, correct? So now I will write f of x is equal to cot x by 2. F dash of x is equal to minus cosecant squared x by 2 into 1 by 2. So the I is of the form integral e power x into f of x plus f dash of x dx, correct? So I is of the form integral e power x into f of x plus f dash of x dx. So you know I is equal to e power x f of x plus c, right? Don't forget the minus there. So now I will be, write that minus, then e power x into f of x is cot x by 2. E power x into cot x by 2 plus. Do you follow? So in all the sums you won't get straight things, so you have to use some trigonometric simplification or maybe some other method, add and subtract like that, and you should bring it to the format f of x plus f dash of x. Whenever you get that e power x into two terms or something like that, no, it will be mostly based on this formula only. Is it clear? Example 3. I is equal to integral e power x into x squared plus 1 by x plus 1 the whole square dx. This is also not straight, and here there is nothing like trigonometry formula and all. So here what I am going to do, now I will write it as integral e power x into x squared plus 1. With that I am going to add and subtract 1. In the next step you will understand why I do this. Okay? Now I am going to combine this and this, and I am going to combine this and this. That is, I will write e power x into x squared minus 1 by x plus 1 the whole square plus 2 by x plus 1 the whole square dx. Right? Do you follow? Now x squared minus 1 you can write as x plus 1 into x minus 1. So e power x into, this is x plus 1 into x minus 1 by x plus 1 the whole square plus 2 by x plus 1 the whole square dx. 1 x plus 1 will get cut. So now I am getting e power x into x minus 1 by x plus 1 plus 2 by x plus 1 the whole square dx. Here it may not strike immediately that if you differentiate you will get this, but you can just think this is of the quotient form. So in quotient form, you know, the v squared will come in the denominator. You have your v squared, so you have to try it out. Let me check here. Supposing I take my f of x as x minus 1 by x plus 1, what will be my f dash of x? Let me apply u by v formula, okay? So I will get x plus 1 the whole square, then v into u dash minus u into v dash. So I will get x plus 1 minus x plus 1 by x plus 1 the whole square. X will get cut. I will get 2 by x plus 1 the whole square. Okay. So now you know this is f of x, that is f dash of x, you can write, and the integral is of the form e power x into f of x plus f dash of x dx. So the answer is e power x into f of x plus c. Okay, write those steps. So I am going to write here straight away x minus 1 by x plus 1 plus c. That will be the answer. So you have to check whether that f of x, f dash of x exactly tallies with the two terms. So this is a bit different. Okay, is it clear? Now let me do one more sum which will be different from this. See the example 4. I is equal to integral e power tan inverse x into 1 plus x squared by 1 plus x squared then dx. Now, when you see the sum itself, you know the formula is integral e power x into e power x only should be there. But here you have a tan inverse x. So the first step definitely will be substituting tan inverse x as t, because we cannot use that formula when it is e power anything else. Only when it is e power x, we can find the f of x and f dash of x. Okay. So what I will do is, I will write my tan inverse x, that will be equal to t. This implies x is equal to tan t, correct? Because I have an x. So x will be equal to tan t. So naturally my dx will be equal to secant squared t dt, right? So I am substituting tan inverse x as t because e power I need only one variable. Then from this I got x is tan t and dx is secant squared t dt. So now my I will be integral e power t. Okay, then 1 plus x is tan t. X squared is tan squared t by 1 plus tan squared t. Dx is secant squared t dt. Okay. So now I will get integral e power t into 1 plus tan squared t, that will be secant squared t, plus tan t. 1 plus tan squared t, that will be secant squared t. Here you have secant squared t dt. So cut this and this. So now I get integral e power t. Let me write tan t first. Then I will write secant squared t dt. I think now you would have guessed, isn't it? Now, if, don't say f of x here, f of t. If f of t is tan t, then f dash of t is secant squared t, isn't it? So now let us write f of t is equal to tan t. So f dash of t is equal to secant squared t. So the integral I is of the form. Now write in terms of t, okay? Integral e power t into f of t plus f dash of t dt. Therefore, I will be equal to e power t f of t plus c. So now the answer is e power t f of t is tan t, f of t is tan t plus c. But don't give this as the final answer because we have to go back to x. What is x now? That is t is tan inverse x, tan t is x, okay? T is tan inverse x. So I will write it here, e power tan inverse x, okay? Then for this tan t, I can write x plus, this is the answer. Is it clear? So I hope you have understood the third model, that is integration by parts 2 times, and how to use the new concept, new formula, and I have given you the example sums. Okay, so work out the similar sums I have told you. Your practice is very, very important. Work it out. In the next video, let us see more. Thanks for watching the video. Share it with your friends and classmates. Thank you.